Welcome to Risk Roundup. It is said that what we cannot create, we do not understand. While the very nature of human mind and the science of intelligence is difficult to understand, there is an intense effort going on to build a conscious computer mind out of computer chips. Understandably, there are growing concerns and questions about building a computer mind from electronic pieces when there is so little clarity about the human mind, science of intelligence, and the very nature of human consciousness. From the beginning of times, the power of imagination has helped we the humans explore the unknowns, evolve, and change the world around us. We have fundamentally transformed the geospace. The same power of imagination will perhaps continue to help us explore the unknowns of the cyberspace and space and change the reality around humanity. Imagination has always been an indicator of human intelligence. While imagination is a creative power that is necessary for inventions in cyberspace, geospace, and space, the same power of imagination is driving neuroscientists today to understanding the human intelligence, imagination, and where ideas originate from the human brain and mind better. To discuss how much we know about the science of intelligence further, I'm honored to welcome Professor Risto Ilmoniemi to Risk Roundup. Professor Risto Ilmoniemi is the head of the Department of Neuroscience and Biomedical Engineering, Aalto University School of Science, Finland. Welcome, Professor Ilmoniemi. We are honored to have you on Risk Roundup.
Thank you. It's a pleasure.
Wonderful, Professor. So, knowing what determines intelligence is perhaps the biggest question we face today. While there are many theories of intelligence, and intelligence has a broad meaning covering so many different mental activities, is intelligence a single general ability or a set of many abilities?
Well, this is a very difficult, but it's an essential, important question, I think. My background is in neuroimaging and non-invasive brain stimulation and neuroscience, but the intelligence itself is not really my core question. But I think that the development of intelligence in evolution of different species is an essential aspect. So animals, long time ago, when they encountered new environments and new conditions, had this pressure to survive, and the fittest survived, and first we got simple kinds of intelligence, simple decisions depending on the surroundings and the situation. So this is one explanation for the emergence of intelligence. I don't think it is really understood. The human brain is really very complex. We know a great deal about the functioning of the neurons and the interaction of the different parts and how people behave in different situations. But how the coding in the neurons, neuronal signaling, is related to intelligence is not so well known. On the other hand, I would say that we have learned about intelligence from artificial neural networks. It's a quite long history already from the 1950s or 60s in modeling or making computer software that can mimic some aspects of intelligence, like
yes.
Finding correlations between different things, associative learning and learning itself. Difficult question.
It is a complex question, and you are right. There is still so much that is not known. And while human mind seems to be a set of cognitive faculties that includes so many different things like consciousness, perception, thinking, judgment, and memory, it seems that they are all interrelated, interconnected, and perhaps collectively determining the level of human intelligence. So it seems from what we have been reading from the published literature. However, we still don't have a clear understanding of all the cognitive faculties that allow us clear understanding of human intelligence. And amidst that, when we say a person is intelligent, that this person is intelligent, that person is intelligent, do we have a credible approach to measure intelligence?
Well, operationally, there are intelligence tests. In that sense, one can easily measure intelligence. It's always defined by the maker of the test. So we have standard intelligence tests, but understanding of what it really is in terms of neuroscience is at a very early stage.
Yes. Yes, that is true. Now, in recent years, it is reported that the structure of the adult human brain changes when a new cognitive or motor skill, including vocabulary, is learned. This perhaps changes the level of intelligence and nature of intelligence as well. So, how is the evolution of human intelligence closely tied to the nature of the human learning? Do you see that depending on what we learn, whether it's a language or whether it's some other skill, that the nature of the human intelligence and also the brain evolution, it happens all in parallel? Do you see a correlation between that?
We don't have much intelligence when we are born, but the evolution has given us the ability to learn and obtain intelligence during our lifetime. So there's a big part of the intelligence, or the major part of the intelligence after the machinery that we have in the brain, is in the learning as a child and through the whole life. So people who have not been able to, have not lived with other people, they have never created the real human intelligence. So we have inherited the ability to learn, but then we really have to invest a lot of time in learning and developing the intelligence.
Right. Now it is, yes, please go ahead.
It's nature and nurture, both are important aspects of intelligence.
Yes, very true. Now, it is reported that as a species, humans exhibit broad range of intelligence, broad different nature of intelligence, of which heritability, genes, it accounts for about, I think, 50%. The fact that there are genes which control intelligence provides us a platform for evolution and natural selection to act upon. Now, while genes certainly play a role in human intelligence, it is about 50%. Is the other 50% the role of environment, like how is the family upbringing, how is the education system and all other variables, do they come in play in the other 50%?
Yes, it's our life and surroundings or circumstances that defines the rest. I don't know where the 50% has come from, but maybe it's a good guess of half and half, genetics and learning.
Yes.
Of course, as a child, you learn automatically when you interact with your parents and other people. When further development of the intelligence requires some effort, like you go to school and so on.
Yes, very true. Now, there is a genuine concern that the human brain evolution has become stagnant and that it would likely cease. Now, with this technology-driven growth and expansion that we see across nations, the humans need to do most manual and mathematical, over the years what we were doing, all the manual and mathematical work, the need for that will be greatly diminished because of all the technology developments that has taken place and is ongoing, and the new technology emerging. So while the work for day-to-day survival will be greatly lessened, the fear of survival of the human species will be greatly increased. Do you see that this will impact the evolution of human brain, mind, and intelligence? Do you see the possibility or probability of that?
Well, I don't think nobody knows what future will bring, but evolution will certainly continue because it will be defined by what kind of people have more offspring, what kind of people have more children. That will define the future of evolution of humans. Now, there are many people who will require and benefit from mathematics and development of skills. But how that is related to the number of children, who knows?
Yes.
You see, the more children a certain kind of people have will define the fate of evolution. But the difference with the past, especially when we are further and further in societies where everybody has enough food and shelter and so on, then the survival of the fittest argument doesn't work anymore.
Yes.
It's a question of who will have more children. So I don't think the evolution is very much going to be defined by the skills.
Yes, yes. So it seems.
That this will lead to the situation that educated people may have fewer children than others, and that will then may have a big impact on humanity. But this, you don't know. We don't know what happens in the long term, because it's going to take many generations before there will be
Yes, yes, because
changes.
yes. That is true, because a lot of people feel that with all these new digital assistants that we see, Cortana and Siri and Alexa, they help us get up in the morning, and they help us, with all the questions that we have, they come up with the answers. They do all kinds of things for us. So what people are concerned that what intelligence and skills will we need when all these machines are doing all the work for us? So that is a genuine concern. But we will see in the coming years what kind of skill development is necessary for the humans to survive, and what they need, what they don't need, and how it's impacting the brain and the intelligence and the evolution process. I think it will take years before we understand what is going on. But there are some who say that we don't understand how to effectively create artificial intelligence because we don't understand human intelligence clearly enough. So do we need to understand human intelligence clearly before we create artificial intelligence?
I don't think so. I don't think so. If you have some aims in your artificial intelligence, one can develop technology that addresses these aims and these goals and kind of. And I don't think the artificial intelligence necessarily has to mimic human intelligence, although we have learned many things from human intelligence. In the early stages, people wanted to make software that would do on the surface level similar things as humans, but that one cannot program a computer to do everything in a pre-planned way. It has to be a learning system. The true artificial intelligence has to be a system that learns itself. And the internal workings of these devices are not necessarily and probably not usually similar to the human machinery in the brain.
Yes, yes. Now, even if scientists develop the technology to create an artificial brain, there is no evidence that this process will automatically generate an artificial mind. There is no guarantee that this machine will become suddenly conscious. What are your thoughts on that? That we don't understand the nature of consciousness in humans, in us ourselves. So how do you see a possibility that we'll be able to create a conscious mind in a computers?
Well, I believe in the possibility of machine consciousness. Of course, I don't know, but I haven't heard or read or thought about any logical argument saying that it would be impossible. Therefore, until proven, it is a possibility. But you're right. We don't understand the consciousness, that how it is possible to start with. Of course, we know that it exists, and well, there are many scientists who think that machine consciousness is impossible. They may have a belief that you need a certain substrate, that is a biological substrate, to maintain or establish consciousness. There are others who think that as long as you have a certain kind of information processing system, like the brain, equally complex, it doesn't have to be identical, but equally complex, equally capable, and the learning system, that it will automatically have consciousness.
Yes.
We don't know yet. Nobody has demonstrated machine consciousness yet. There are philosophical articles on this possibility, but we will need to have machines that are conscious, and then we need some method to measure consciousness. That's another problem, how to do that. And there are many people who believe that it's impossible even to measure whether a machine is conscious or not, is conscious or not.
Yes. Yes, very true. We do need to come up with a ways to figure out how to do those measurements. How would we know that it's a conscious machine?
Even if it behave intelligently and maybe in a humane way, how do we know that it's actually conscious?
Yes, very true. Very true. That is the question. Now, although artificial intelligence is becoming more and more a part of everyone's everyday lives, understanding how the human brain produces intelligent behavior is still perhaps one of the greatest challenges in science and technology today. I mean, we are getting closer. We are because of the brain mapping advances and the initiatives across nations, we are at a point where there is a hope that we have a better understanding, and we are going towards getting some sort of clarity about how the intelligence process works. Now, while science knows no boundaries or borders, and neither does human imagination and innovation, how are technological innovations from across nations helping us decode human intelligence? Because we do, to understand what is, to do the brain mapping and to understand what brain architecture or what processes are happening and how are all the different things working in our brain, we do need technological advances. Without that, it's not possible to do the brain mapping, human brain mapping, or to create even a computer intelligence. So what kind of technology innovations you feel that are absolutely essential, and where we have reached, which technologies you think that have played a major role, and in the coming years to do a better job in understanding the science of intelligence, irrespective of whether it's a human intelligence or a computational intelligence, what technology innovations you feel are necessary and essential for us to take the next step forward?
I think there are two things. One is neuroscience. We are learning faster and faster how the human brain and simpler brains, animal brains, work, how they work, the neurons are connected to each other, how they communicate, and what kind of algorithms there are in single neurons and in the network. So this information is going to grow. Our knowledge of the brain is growing very fast, but that will not solve the problem of consciousness. Maybe it will tell us about intelligence. We already know much about perception, that's part of intelligence, and actions, decision making, and so on. But consciousness is much more difficult. And the other aspect, so in addition to neuroscience, the other way to learn about intelligence is artificial intelligence. So this is, as you started this discussion, if you pointed this out, that if you can't build it, you may not understand it, or something like that. And I really think that is true. So if you can artificially create software or machinery that can do tasks, then you understand something about this task performance, even if it's not exactly the same as in the human brain, but you have demonstrated that it is possible to, for example, have an automatic learning system. So just give examples of, let's say, pictures and many pictures, and the system can learn to differentiate between different classes of, let's say, men and women, old and young, and all kinds of things. Then I would like to continue a little bit about the concept of consciousness. That how could it ever be understood? There is this so-called hard problem of consciousness, which is really very hard to imagine how it can be solved. But I believe is that the consciousness, the ability to feel, to have qualia, the sensations of being alive and feeling the environment, so feeling pain, for example, that's truly hard, but it's, I think it is a very simple thing. So consciousness is probably a fairly simple thing. Very simple animals may have this awareness or feelings like pain, for example. If you observe them, animals also seem to feel things. So what I think is that we learn more and more about the brain, about neuroscience, artificial intelligence, but then the riddle of consciousness needs some idea, somebody who understands, who gets an idea of how does it really work. Nobody has done that yet. There are some ideas, but probably all of them are wrong, I think, and so far. And then if the explanation of consciousness has some experimental predictions, then one can, if the theory is testable, then maybe finally we'll understand consciousness. But nobody has any idea at the moment, I think, what kind of solution that would be.
Yes, very true. Very true, very true. Now, it is said that the tremendous energy and computational efficiency of the brain, if we understand that better, maybe it will inspire new ways and new principles of organizing our computers and especially data centers. Do you think that the path to discovery of the fundamental algorithmic principles on which cortical computation is based, that it passes through the language? What is the correlation you see? How is studying what makes language so well adapted to our minds that it would uncover important insights about the computational architecture of the brain? Do you see the relation there?
No, I didn't really get it. So the relationship between language and...
Yes, language and the how it changes the human brain architecture, and how the path to discovery of the fundamental algorithmic principles on which cortical computation is based, that there are many scientists says that it passes through the language. Is that what the common consensus is among scientists?
That's a good question. I think we have already learned a great deal about how the brain works, including language, by observing connectivity and the interplay between different parts of the brain via the internal connections. So the different parts of the brain are sending signals to each other, and And there's an old notion by Donald Hebb of neuronal assemblies, and it is still under active research. And I'm a believer there's evidence for the idea that our concepts, like the concept of a pencil or pen or person, in the brain are coded as these neuronal assemblies, meaning that there's a certain pattern of activity among different parts of the brain, among different neurons. So when this pattern of activity emerges, then we have this concept in our mind, or it can also be unconscious, of course. But anyway, it's somewhere in the brain, and I think artificial intelligence has something to learn from this as well. It already has learned that it's really in the pattern of activity in the network that defines concepts, and this doesn't need to be explicitly programmed. You just have to build a system where it's learning by itself. It's self-organizing depending on the information obtained. This is how we form concepts. So we already have some concepts in our mind. Let's say a round ball and then some color, and then we see a red ball, then our brain connects these two different concepts, and we have a new concept that is a red ball. We can give it a new name, and then our language areas in the brain are related to this concept.
Yes.
Neuronal assemblies, that is the keyword, I think, in understanding much of our language and concepts and how the brain works.
Yes. So it seems. Now, both brain and computers use electrical signals to send messages, and they both transmit information. Now, it seems that the human brain uses chemicals to transmit information, whereas in computers, it uses electricity. While the connected computers through electricity are able to transmit information, we humans, we still don't have that capacity to transmit information in a form that transcends the geographical location or physical barriers, more like, telepathic communication. Do you see a possibility of telepathic communication happening, with the advances in this brain research, that we will be able to figure out how to have the telepathic communication between, humans? Do you see that possibility?
I don't, and not many scientists believe in telepathy without some physical means. Of course, in the electronic world, there are the electromagnetic waves, radio waves that transmit information. The brain is not able to send electromagnetic signals at sufficiently high power to reach other brains, and the receiving brains do not have receivers for electromagnetic fields. So I think that is not a feasible possibility.
Well, it would be exciting if we are able to understand how the whole brain actually works and how to use the full potential of the brain. Maybe that would be possible, but again, we are nowhere near that. But that fascinates me, and I always think about it, whether it would be possible to have some development like that.
Fascinating. I mean, new discovery about the world would need to, some unknown mechanism would need to be found. But maybe we could have artificial telepathy. So.
Yes, you never know. We can implant chips into, human beings, and through that we can have that kind of communication. So if not natural, we will be able to create something like that, hopefully, in the coming years.
We already have mobile phones.
Yes, absolutely.
But like telepathy in a way.
Yes, we can have mobile phones, chips embedded into human body, and then we won't need the external phones. We will be able to communicate directly. So we will see what happens in the coming years. But that is certainly possibility and fascinating idea if we are able to make that in a reality. Now, both the brain and computers have a memory that can grow. Computer memory grows by adding computer chips. Memories in the brain grow by, I believe, stronger synaptic connections. However, there is not much understanding in how to strengthen those synaptic connections to improve or increase human memory. I mean, of course, we will be able to add chips into brain, and by that we will be able to make some changes. But naturally, how to strengthen the synaptic connections, we have not made much advances in that. Now, as computer memory advances rapidly, it seems that human memory in the natural state, of course, is going to lose the battle and fall behind. Will we be able to grow human memory, and will human memory be able to compete with the advances in computer memory? Again, there are two paths to this. One is the natural and one is the man-made. If by implanting chips, I'm sure that we'll be able to grow our memory, but naturally, do you see that possibility?
Well, first of all, I don't think why we would need to win this competition. We have other machines that are stronger than we are, and they are helping us. So maybe the same will happen with artificial intelligence. We already have computers that are far faster in simple tasks, like computational tasks, than we are. And eventually, maybe that computers are more intelligent than we are. But then to your question, can we enhance our own intelligence?
Yes.
Strengthen in our natural learning? Synaptic strengths are changed. They may be increased, strengthened, or weakened, depending on the situation. In both can be actually learning, weakening and strengthening. The brain already has a great capacity. It's to a large extent also how we use it. There are some individuals with the same size of brains who have virtually perfect memory. They memorize everything. So we, as human beings, thinking and feeling human beings, we need a system that limits our memory so that we do not suffer from bad memories. So,
Yes, that's true. I mean, there are, see, the artificial man-made in memory enhancement is certainly going to be possible, but there are a lot of people now saying that why do we want to make machines more intelligent? Why do we want to make computers that intelligent? Why can't we just make human species more intelligent? Why don't we come up with ideas and innovations by which we make the humans much, stronger in terms of intelligence and innovation capabilities and imagination, so that then that fear that is there in humans currently, that what will happen tomorrow if the computers become suddenly they reach the highest level and they that they will threaten the human species itself. That fear is that we put our existence at risk. So why don't we make humans more intelligent? So that is understandable concern and understandable initiative, that let's just make humans more intelligent. And to do that, we will have to create all these capabilities. We'll need to enhance our memory, we'll need to increase our intelligence, and we will need to do much more, so that a human brain is performing at much better capacity than computers. So that's where a lot of scientists are thinking about how to create that kind of capability for human brain. So we'll see what happens in the coming years. But it seems that both brain and computers have evolved over time, and computers have been around only for a few decades, but they have evolved so much faster than the human brain. And this is mainly because of the rapid technological advancements that have made computers faster, smaller, and more powerful. it seems that that process is going to continue, that the computers will keep getting faster, smaller, and more powerful. Now, when we look at humans, at first, evolution proceeded by natural selection from random mutations. That's what, is commonly generally believed. Now, if we are entering in a new phase in which we will be able to change and improve our DNA, how do you see the man-made evolution advancing, especially from intelligence perspective?
Well, genetic changes for the human intelligence, I think that's very fine in the future. Maybe you can do that in simple animals at the moment. But well, there are, of course, many ways you can use to try to improve intelligence. Pharmaceutical methods, brain stimulation. The most effective probably still is education. So I would put my money on education, better education for everybody. Not only developing intelligence, but also what we really need is wisdom. How can we wisely use artificial intelligence? It's still under our control. But I think if computer science continues to develop the way it has developed, I think it's a losing game. The computers are going to win in all those tasks which we are able to program. Maybe the computers will never be conscious. It may be that they will, but we don't know. It depends on what happens. Yeah, there are dangers in that if computers are given autonomy and they are connected to, let's say, robots or other machinery that can influence the world. Yes, there is a danger, and of course, yes, even before that, people can use any technology in harmful ways. Therefore, we need wisdom, better education to prevent that from happening.
Yes, that is true. That is true. We need that proper environment in which individual students, irrespective of any age, they are able to learn and develop, acquire new skills. That is a necessity of the time. I mean, there is no other way. Every human being will have to learn the technology and many other areas. There is no other way that we can move forward. We have to keep progressing. Now, both brain and computers can change, and they both can be modified under various circumstances. Now, the brain is always changing and being modified. There is no off switch for the brain. Even when we are sleeping, the brain is still active and working. Now, computer only changes when new hardware or software is added manually, or something is saved in a memory. So there is an off for a computer. When the power to a computer is turned off, the computers are off. There are no signals that are being transmitted at that time. So based on the understanding of neurosciences and the brain research that is going on, do you see evolution in computers where, irrespective of electricity, we can keep that on? Do you see any initiatives where scientists are working on that?
Well, computers will always need energy of some form, either electrical energy or some other kind of electricity. Maybe there will be, in principle, one could have biologically built artificial computers as well. So when we sleep, we need energy, as much energy as during wakefulness. The brain is active during sleep and requires energy. And the computers, if you want to keep them active, always need energy, as far as I can understand. But I don't think that is a limitation, because we have energy.
Yes.
From different sources. And electrical energy is the easiest kind of energy that can be used for computers.
Yes. Now, it seems that both brain and computers are used for storage and processing of information. and they both execute tasks using either electrical signals or chemical signals, and in the human brain through neuron to neuron. Now it seems that there are some efforts, initiatives going on to uh, upload the information in a human brain, that we can update the brain. We can just update the brain by and transfer all that knowledge, by those updates. Do you see that? Do you know about where we stand with the advances, or what the research, the state of the research of updating the human brain? Are we at a point where it's possible that we can update a human brain?
I'm not really aware of this aspect, this kind of developments.
Because I think scientists have discovered, I read somewhere that scientists have discovered how to upload knowledge to human brain. I just don't know what is the state, because I didn't get much information on that discovery.
Isn't the best way to upload information is by reading and observing the environment, but it's also getting information to the brain. The eye is very good mechanism to transmit information into the brain. But you're talking about artificially doing how
Yes.
that could be done artificially. You can electrically stimulate the brain. There are already some what is it called, prostheses or something like for the blind, where an array of electrodes can be put in over the visual cortex, where you can artificially produce sensations like images. But that's on a very crude level at the moment. But anyway, in principle, it can be done, that you directly influence the neurons in the brain. You can even do certain things non-invasive, the brain, transcranial magnetic stimulation. You can activate parts of the brain. And also in the other direction, there are implants connected to the brain with which you can control robotic movements. This is already used in some cases where people are paralyzed. They cannot move their limbs, or by thinking, they directly can connect the artificial limbs to the brain and control these robotic parts of your body with the thoughts. The way I'm moving my hand, that is like a miracle. It moves. I'm just thinking and it moves. But you can do that artificially also. But that's still at a very crude early stage. So there are some people who think that this may lead to more really efficient ways of artificial communication with the brain. But
Let's hope so. Let's hope that there is a better, efficient way to do that. But now there's also, this is a very interesting, area where I hope that there is more advances and development, because if we see human brain have both short-term and long-term memory, as well as the capacity for dealing with immediate issues. But how does the brain process short-term and long-term memory? And why is not all the memory active in human brain like in computers? In computers, you just, whatever information you want, you immediately get it. It doesn't matter if it was stored in the computer like 10 years before or 20 years before. Accessing that doesn't take time. The processing speed is so fast. But in humans, if we have created some memories like 10 years back or 20 years back, even though it is stored in human brain, we cannot process it that quickly enough. We are not able to recall that, and we are not able to retrieve that information as quickly as how the computers would do.
right. Well, there are two things here. One is that the clock speed of the brain is really very slow compared to the computer. So small number of operations per second in the brain per neuron, whereas in the computers it can be billions of operations per second. And the other thing is that accessing the memory in the brain appears to be associative. So, if, and this is not always working the way we would desire. But what we observe is only the conscious part of brain action. The brain is doing many things that we are not aware of, like controlling our breathing and posture and background operations. Many control operations are happening, and we are not aware of those. They're also using memory, memory in the brain. So conscious thoughts are connected to a very small number of memories at a time. So there's very little room in the conscious memory at any given time. You can think about only one or two things at a time, not many. So it's very interesting, the comparison between computers and humans is very interesting. But you can think about the computer without the concept of consciousness. So you can imagine, okay, all the memories are there immediately available, but probably if the computer would be conscious, if it would have one consciousness, it would access only a very small part of its memory. Do its conscious thinking at a time, that's what I think. Because I think consciousness is a very simple thing. We don't understand it, but it's still simple.
Well, I hope that it is that simple to understand that. I'm not sure.
It's not simple to understand, but it is a simple thing.
Yes, yes. Now, what do you think are the barriers to progress in cognitive, behavioral, or neuroscience that could be targets of opportunity for computer science research? Because understanding all these different processes and how the whole our brain works in the human brain based on the brain mapping research or neuroscience research, that's still a very complex task. I mean, we have to go bit by bit because there's so much complexity there. But in computers, if we try to replicate by imagination, that how would this process work, and if we create that process in a computer, maybe that would help us advance the neuroscience research, probably more effectively, because all these new models of machine learning inspired by neural architecture, they are going in the direction of inquiry or biomimetic algorithms, and they are all kind of successful. They are doing they're rapidly progressing, and they're giving us the success that we are looking for. And while this success with this success, it can also provide us insight and inquiries about how it will influence our thinking about the brain, how it may function, and how we can test those ideas. So maybe we can do the reverse engineering here. We develop those processes, we develop those systems effectively in computers, and then try to understand that in human brains so that we can advance further. Do you see that opportunity for computer science research?
Well, we have learned a great deal already from the brain, and we can mimic many things that happen in the operation of neurons and their connections. One of the difficulties, of course, in studying especially the human brain, that it's hidden inside the head and skull. There are not many volunteers who let their brain be open for study, and even if that happens, there are so many details, so many neurons. There are tens of billions of neurons.
Billions.
If we would know exactly what happens in each, we would not be able to comprehend it easily. So I think still it's a good idea to study. If you really want to study how the brain processes information, the good idea is to study simple circuits. Well, there are investigators who are studying simple animals like the epilucia, or simple parts of the animal like the retina. Um, and we have learned from these, and some people are using this information for artificial intelligence. Very often, I think the artificial intelligence development is not so well connected to neuroscience. In fact, you mentioned machine learning. Typically, what happens in the computer when machine learning algorithms are doing their thing, the investigator, nobody understands what is really happening in the computer, because machine learning has created internal mechanism and internal logic that it is
Yes.
available, but because it's so complex, it is hard or maybe even unnecessary to understand in detail. The concept of machine learning as used now is can be simple. Deep learning is simple as a concept, but when you implement it, there are many details inside that you don't need to know.
Yes, it is very complex. You are absolutely right about that. But there is also one fact that the computer scientists and neuroscientists, they all work in silo. There is not much collaboration, cooperation, or joint initiatives. If they all work together, maybe we will be able to understand these complexities of deep learning, or how the human brain functions, or how the human brain systems work. Maybe we'll be able to come. We'll have more clarity if there are some collaborative initiatives. But even within neuroscience, if you see, each individual neuroscientist or each area, everybody is working in silo, and that is, I think, irrespective of what industry we look at, that is the biggest challenge we face currently, that all within a nation also, all its components are working in silo: government, industries, organizations, academia. And if you look at even within a science or neuroscience, that also is the same case. Same are the challenges everywhere, that everything is happening in silos. So it's very difficult to understand that from a system perspective, what are the challenges. But let's talk about the brain emulation capabilities, because it's very fascinating. The mind copying or mind transfer capabilities, it seems that we are a step closer to creating human-like intelligence in computers. Now, it is believed that mind uploading is humanity's current best option for preserving the identity of the human species. So, where are we currently in the whole brain emulation capabilities? Do we have capability that we can transfer the whole human mind capability, or whatever the information is stored in human mind, that we can download that and upload it in a computer in whatever form? Are we closer to that?
That's an interesting question. I have no expertise in this area. Well, if it happens in some distant future, yes, we are all the time going closer to that. I think the problem is both technological and conceptual. So, because we don't understand what really is mind, what is consciousness, then it's hard to imagine what should be uploaded or downloaded when you're uploading or downloading the mind. I want to first try to understand what this would mean. So the extreme way to clone the mind would be to clone all the neurons. That, I mean, make artificial neurons, artificial very large network, equally large as mine, and somehow copy the activity and synaptic connections from the whole brain. Okay, I would imagine that if it does exactly the same as my brain is doing, then it would have my consciousness. But this is a technological problem. It's very hard to imagine how you could measure the brain in such a detail that one could make a copy of it that would be conscious or even functional. But in principle, there's a simpler way if one could understand the concept of consciousness. Because I said I believe mind or consciousness is simple. When we don't meet all the detailed ingredients, if we could somehow measure the important things, okay, maybe you could copy the mind, but it wouldn't really help me because my mind is here. Even if there's a copy somewhere, I wouldn't know about that. I mean, I wouldn't feel it. It would have its own life somewhere else. Well, I wouldn't be opposed, but would it help something? I don't know. That's a very interesting question. And,
I hope
many people are interested in this kind of development, but it's going to be far in the future.
Well, it certainly. I hear it. It certainly is a possibility, and there are. I'm hearing echo.
Echo, not from here.
No, on my side. It's not coming from your side. Let's wait for a minute. Okay, I think it's better. So there are advances happening, and there is certainly a possibility that in our lifetime we will have that capability. And I hope that there is a capability, because then we can leave all the knowledge behind for not only our children but for the humanity. If every single person who has developed some really good who has acquired great intelligence and who has a lot of information to share with the world, that would be a really good way that we can leave behind that legacy, and that collective intelligence, the collective human brain, that will keep advancing the humanity further and further. So I hope that it becomes a reality. I'm sure that there are efforts going on, and I hope that it becomes a reality in near future. Now let's talk about with the same mindset. I believe there are ongoing efforts to create the digital immortality of a human brain. And a team of scientists from Augusta University, Georgia, it seems that they are suggesting that the origins of human intelligence is based on a very fundamental algorithm which they call the theory of connectivity. So do the complex human brain computations rely on relatively simple mathematical logic? Because human brain is so complex, but the underlying computational principle, is it that simple?
Well, the operation of the human brain is based on a large number of relatively simple units. That is, the neurons. They are not very simple, but far simpler than the whole brain. And most of the neurons behave in similar ways. They obtain information from other neurons, the action potentials, the spikes, information spikes that they receive via the synapses, and then depending on the quantity of positive signals in relation to the negative ones, they either send a signal further or they don't send. So that's each neuron is essentially an adding machine in a way. Roughly like adding the information that is coming in and then sending the signal out if the result is large enough or big enough. So yes, the basic principle is very simple, and as far as I can tell. But then the connectivity and the whole how it learns is more complicated.
Yeah, and then also the glial cells. Glial cells also play a major role, right? Because so far the neuroscientists were thinking that they don't play a role, only the neurons play a role. But the glial cells, I believe that now the scientists are coming to terms and understanding that they play a major role. So far they were thinking that the glial cells is just, to clean up the waste that is created in the human brain. But it seems that they play much bigger role. So it seems very complex, even though the underlying principle could be very simple. But I believe that the whole brain chemistry because of the involvement of the glial cells, it could be very complex. And just like human microflora in the gut, now scientists are beginning to believe that they play a major role in not only the human metabolism but also in the state of human mind. The mental diseases, a lot of mental diseases are caused because of the imbalances in that microflora. And who knows that in the coming years that knowledge or that process would be understood much clearly, that is the glial cells and the imbalances in the glial cells could play a major role in how the intelligence functions, or how the memory is stored effectively, or how the memory imbalances or intelligence imbalances or the mental diseases, maybe they all have the glial cells imbalances could be playing a role there. So we'll have to see how the science advances there, but I think that from what we are seeing, that it seems like it plays a very important role.
Well, there are many glial cells, in fact, more glial cells than neurons.
Yes.
In the brain, so they have an important influence. Of course, it's been long known that they provide the sustaining service. They transmit nutrients to the brain and oxygen. But yeah, it's a new finding or a new part of research that studies the influence of glial cells in information processing, and nobody knows whether there's some connection to consciousness. But I think that the high-speed, quick action in the brain is mainly in the neurons. You mentioned gut, and actually the whole body is connected to the brain via the peripheral nervous system. Yes, we are connected to the guts, and that may have significant influence in how we feel and how we are conscious. I would extend this, that we are also connected to the environment. We can be alone without connections to the environment for a short time, but not for a long time. So many people think that really our existence is being in the environment. Part of the brain's environment is the guts and other parts of the body, but also the surroundings. And this happens via the senses. Nobody has yet discovered anything that has to be with telepathy, but we have the senses that connect us into the environment. This is a very important part of our existence, of course.
Yes, very true, very true. Now, the human ability to act and react within the world is fundamentally grounded by perception. Now, because we can control and observe sensory signals at the transducers, the processes, all these processes of vision, touch, sound, taste and smell, they are all some of the most accessible aspects of the brain. Now, what are the mathematical characteristics and latent structure of the distribution of the input of the inputs the computer brain sensors receive? That is the environment within which the computer brain is developing and evolving. What are those mathematical characteristics?
Well, I'm not sure exactly what you mean. Well, one interesting thing is that most of the neurons in the brain are not connected directly to the environment. Most of the neurons are deeper in the brain. So for a while we can function without the sensory input as well. But each, if you're thinking about, I'm not sure what you mean by mathematics in your question.
It's like understanding how biological systems process sensory signals and optimally allocate resources for sensory processing. It will provide us important clues for creating artificial systems that will operate in the natural world. So that is the basic underlying principle of that if we understand that the mathematical characteristics and the latent structure of the distribution of the input of the computer brain sensors, how they receive that from the environment within which it operates, then we will be able to understand all this much more. But it seems that the brain science, let's talk about the big data science that we are developing, that the brain science is going to be the next big data science to create a new computational lens through which to study and connect not only the structure and function of the brain, but also artificial intelligence, computational intelligence, and the biggest problems humanity faces today. So do you think we can think the brain as a computing machine? Do you see that we can approach the brain neuroscience, the brain mapping, the brain chemistry, the brain architecture from the perspectives of a computing machine?
Well, I would say yes. It's a fascinating thought that mathematics is used to explain the brain or describe the mechanisms. And actually, mathematics is used quite a lot at the different levels. So you can mathematically describe, mathematics and physics describes how a neuron works and how simple circuits can perform logical operations needed in perception, for example. In each neuron, if you take the sensory neurons, you press the skin, the harder you press, the higher number of signals, these action potentials go to the brain per second. The harder you press, the more signals go to the brain. So we know this kind of relationships. Now, one important aspect of the brain is homeostasis. The brain wants to stay in an optimal operational state at the moment. So it's not like a computer where you do where you always are capable of doing the calculations as long as the program doesn't have any bugs. But in the brain, there is the danger of positive feedback, and this has happened sometimes in epilepsy, where there's this electrical storm in the brain. In the healthy brain, there's always feedback mechanisms that keep the brain in its operational state, optimal stage, and we are in the study of dynamical systems. That's a very general mathematical theory of how dynamical systems work, and that has brought us some understanding about the brain as well. So my point really is that yes, mathematics is used at very different levels of neuroscience.
Yes, very true.
And maybe there's a place for big discovery from that direction as well.
Well, let's hope so. Let's certainly hope so that we get those big discoveries. Now, connecting brain, mind, and body is advancing very slowly but steadily, and it's addressing big questions like how do we learn, how do we communicate, to how do we process. Now, these advances are very important for us because we can, based on that, we will understand the global systems of a digital global age, the mapping of global systems to understanding the complex interconnectedness and interdependencies of nations, its government, industries, organizations, and academia. In cyberspace, geospace, and space, it depends on the advances we make in connecting brain, mind, and body. So where the neuroscience research goes, how the advances is happening, it's going to play a major role because the implications are big, because based on that we will be able to create much more in a digital global age. So how do we connect the dots through theories and methodologies relating to low-level mechanisms of neural computation, to more abstract information processing and systems, to high-level behavior of this digital global age? And what computational tools and environment you see that is necessary to support this replicable, scalable science, to move beyond the laboratory to the reality of this human species, and to this digital global age?
Well, clearly, all human behavior is based on the brain, but these questions are really hard. How does this influence our psychological behavior and actions in society, government, and so on? So I think so far we need different levels of description: the neuronal level, the psychological level, the societal level. Different sciences have been developed for that. But I think it's very important to try to bridge the different levels of description. Some people are trying to do that, but I think we are still quite far from understanding societal events like politics or on the basis of neuroscience. There are some advances, for example, in the science of decision making. For example, economic decision making is studied by what is called neuroeconomics. You can find that the frontal cortex, for example, is controlling our decision making. But it's a long way towards real understanding of how this influences our behavior in social networks.
Yes, very true. What would you like to tell our global viewers and listeners about your institute's efforts towards science of intelligence, and where would you like the young generation, the young people, students who are fresh out of college or in high school, or who has a desire to make a lasting legacy, to create what is not there, so that not only the neuroscience, the brain science, the human intelligence advances, but also the computational intelligence advances and the overall intelligence of human species as well as the computers advances? What would you like to tell them where they should put their effort?
Well, there are so many different people, so it depends on the person and the interest. There are many things people can do. They can study the operation of the brain by using neuroimaging and neurostimulation technologies, psychological tests, and so on. But and then the other aspect is, of course, development of computer science, including artificial intelligence, also hardware. So it depends on the person what is of interest. But if you're really interested in how the brain works and what these deep questions of the mind and consciousness are, then I would advise people not to believe in authorities. To think yourself. Of course, you have to read what is known already to some extent, but what we need is bright minds and new ideas, and then testing these ideas.
Yes, very true. So thank you so much, Professor Ilmoniemi, for participating in Risk Roundup today. We appreciate your thoughtful insight on science of intelligence, and I'm sure our global viewers and listeners will benefit tremendously from the information you provided on the science of intelligence, human intelligence to computational intelligence, and its challenges and the future that we are looking at. So even if a single individual or entity can come up with an idea to understand the complex science of intelligence and innovate based on the understanding they receive from this discussion we had today, this Risk Roundup dialogue has been of service, and we thank you for that.
Oh, thank you very much.
Wonderful. So since there are no limits to intelligence imagination, there are no limits to progress and advancement in humans. It is the imagination that will help us create the worlds that never were in cyberspace, geospace, and space. But without intelligence imagination, we go nowhere. Risk Group Cybersecurity Risk Research Center and Strategic Security Risk Research Center are created for this very reason, to identify, evaluate, and manage the risk facing NGIOA and CGS, that means nations, its government, industries, organizations, and academia in cyberspace, geospace, and space. We at Risk Group believe that risk management, security, and peace walk together hand in hand. Though security is related to management of threats and peace to the management of conflict, risk management is related to management of security vulnerabilities as well as management of conflict. And it is not possible to conceive any one of the three without the existence of the other two. All three concepts feed into each other. We believe that the security we build for ourselves is precarious and uncertain until it is secure for everyone across nations. Tradition becomes our security, so if we build a culture of managing risk effectively, it will lead us to security, and security will lead us to peace. Let's manage the existing and emerging risks together. For more information on the risk roundups, to watch the risk roundup videos, or hear the risk roundup podcast, please go to riskgroupllc.com and do not forget to subscribe and share. Until next time, I'm Jayashree Pandey, host of Risk Roundup, signing off. See you next time. Thank you.